picture this: a lone wanderer, drifting silently through the frozen outskirts of our solar system. Without warning, it erupts in a burst of light that blinds the darkness. That's what happened on September 26th, when Comet SWAN, catalogued as C 2025, R2 suddenly ignited, glowing 5 times brighter than astronomers predicted. Then, as if the universe itself answered that flare with another, the sun struck back. Just 48 hours later, an M6.4 solar flare exploded from the sun's surface, one of the most powerful, in months, ejecting a wave of plasma and magnetic fire directly into the path of Comet SWAN. Now, scientists are watching with breathless anticipation, because when a massive solar storm meets a comet with a tail 5 times wider than the full moon, the results can rewrite what we know about space weather and cosmic chemistry. And here's the twist: on October 21st, during the darkest night of the new moon, Earth will stand between the storm and the traveler. What happens next could illuminate the sky or reveal something we've never seen before. Stay with me, because this isn't just a story about a comet. It's a countdown to a cosmic collision between light and shadow, between the sun and SWAN, just days before the comet's outburst. 2 powerful nova explosions lit up the night sky: V 7994 Sagittarii and V 1935 Centauri. These stellar eruptions released intense waves of X-rays and gamma rays, bathing our solar system in high-energy light. Then, almost like a cosmic chain reaction, Comet SWAN suddenly flared to life on September 26th, glowing brighter than predicted. Then almost instantly, the sun answered back with its strongest eruption in months, a fierce M6.4 solar flare that launched a coronal mass ejection into space, directly toward the path of SWAN. It felt like the cosmos itself was setting the stage for something bigger, connecting events across light years into a single dramatic moment. This isn't the first time a mysterious visitor has shaken the solar system. Back in 2017, the interstellar object known as Oumuamua passed through the inner solar system and left scientists speechless on the very day of its closest approach to the sun. The 2 strongest solar flares of that weak solar cycle erupted, and just 1 day earlier, Earth was rattled by the largest earthquake of the year. A magnitude 8.2 inches Mexico. Too many. It felt like more than coincidence. It was as if the universe itself was weaving invisible threads, linking comets, flares, and even the shifting of the Earth. One of the most breathtaking features of Comet SWAN is its colossal tail. Astronomers estimate it stretches more than 2.5 degrees across the sky. That's 5 times wider than the full moon. To put it simply, if you hold out your hand and use your thumb to cover the moon, the comet's tail would spill far beyond it, filling a huge section of the night sky. Now imagine what happens when a coronal mass ejection, essentially a solar hurricane, sweeps across that giant plume of gas and dust. The tail could ripple, disconnect, or even glow brighter than before. To truly understand why astronomers are on edge, we need to look at the timeline. Every date tells part of the story. On September 12th, Comet SWAN reached perihelion, its closest point to the sun, already releasing vast amounts of gas and dust. Then came September 26th, a sudden outburst, boosting its brightness beyond predictions. Just 2 days later, September 28th, the Sun fired off that M6.4 flare and hurled a coronal mass ejection toward the comet. And now, all eyes are on October 20th and 21st. That's when Comet SWAN will make its closest approach to Earth about 0.26 AU, or roughly 39 million kilometers. What makes this even more extraordinary is the cosmic stage October 21st is also the night of the new moon, when the sky will be at its darkest. And on that same day, the interstellar object 3, I Atlas, will align behind the Sun, adding another layer to this rare celestial geometry. A night of darkness, alignment, and cosmic tension, something humanity may never witness again in our lifetimes. What makes Comet SWAN even more intriguing is the path it takes. Unlike some comets that dive in at steep angles, SWAN's orbit lies almost perfectly along the ecliptic plane, the same flat sheet where the planets circle the Sun. That means it's moving right through the stream of solar wind. Fully exposed to every outburst, the Sun launches into space on September 26th. Its orbital angle measured roughly 354 degrees by September 28th, shifting closer to about 45 degrees relative to Earth and the Sun. This geometry matters because any eruption on that side of the Sun has a direct shot at the comet. And then comes October 21st SWAN. The Sun, Earth, and Interstellar 3, I Atlas will all be positioned in a rare alignment, creating a stage for cosmic fireworks. To understand why this matters, we need to talk about what a coronal mass ejection really is. Imagine the Sun suddenly hurling a gigantic wave of plasma, billions of tons of charged particles into space. That's a CME. When such a storm crosses paths with a comet, it doesn't just pass by quietly, it slams into the comet's delicate envelope of gas and dust, forcing the tail to ripple, twist, or even snap off completely. Astronomers have captured this phenomenon before comets like NEAT, Lulin, and even 67P all had their tails violently torn by solar storms. Now, Comet SWAN could be next. Another reason Comet SWAN has captured so much attention is its sudden surge in brightness. Before the outburst, its apparent magnitude was hovering around 6.5, just beyond what the human eye can normally see. But on September 26th, it spiked to about magnitude 5.7. That may sound like a small jump, but in astronomy, every single step in magnitude equals 2.54 times brighter. That means SWAN suddenly became nearly 7 times more luminous. Since then, its brightness has held steady around 5.8, defying the expected light curve. And if this trend continues, by mid-October, the comet could cross into naked eye territory visible without any telescope at all. So, get ready. The chance to witness Comet SWAN with your own eyes might be just weeks away. The surge in comet activity comes at the very moment the Sun itself is growing restless. Over the past week, X-ray flux readings from NASA's GOES satellites have shown a steady climb. On September 22nd, solar activity hovered near the quiet class range. But then, day by day, the readings pushed higher until finally, on September 28th, the Sun erupted with an M6.4 flare, the strongest since June 19th. Sunspot region AR 4 2, 3, 2. The source of this eruption hasn't even rotated to face Earth directly yet. In other words, the most active part of the sun is still turning toward us, and more flares could be coming. The storm we've seen may only be the beginning. Scientists agree on one thing: coronal mass ejections can and do tear apart comet tails. We've seen it happen with comets NEAT, Lulin, and even 67P during the Rosetta mission. The physics is clear: when a storm of plasma slams into a comet, the tail responds violently. But the controversy begins when people suggest the reverse, that comets might somehow trigger solar flares. Some point to curious timing, like Oumuamua in 2017 or SWAN now in 2025. But correlation is not the same as causation. What's undeniable, however, is that comets offer a natural laboratory. By watching how their tails react, scientists can study plasma physics on a cosmic scale knowledge that could even help us understand and predict solar storms that affect Earth. And Comet SWAN is about to become the next big experiment. What makes the story even more fascinating is how multiple cosmic events seem to line up just days before SWAN's outburst. Two nova explosions lit up the sky: V7994 Sagittarii and V1935 Centauri. Those blasts sent powerful waves of X-ray and gamma-ray radiation washing across our solar system. And right after, SWAN erupted with brightness, followed by the sun unleashing its strongest flare in months. To some, this is just coincidence. To others, it suggests a deeper cosmic rhythm, that distant stars, comets, and even our own sun are linked in ways we don't yet fully understand. And October 21st may be the day this cosmic rhythm reveals itself. What happens next is anyone's guess. Will the CME rip apart SWAN's tail, or ignite another surge in brightness? Could October 21st reveal a spectacular cosmic show or something entirely unexpected? One thing is, certain astronomers around the world will be watching closely, because events like this don't come often. The geometry, the timing, the alignment. It's a once-in-a-lifetime stage. And here, on this channel, we'll keep you updated every step of the way, so when the skies put on their next great performance, you won't miss it. Stay grounded, stay curious, and get ready, the cosmos is about to speak. Subscribe now, because the story of Comet SWAN has only just begun.